Well, this is a demonstration of the fundamental theorem of calculus. It says integrate some function and then find the derivative of that, and the two are going to cancel each other out. Well, there is one small detail, and that is that this itself is not just the variable x, but this is the function x cubed. So we're going to be taking that and substituting it into a function. Then if you take the derivative and you've got something substituted into a function, the chain rule says you eventually have to take the derivative of that. So somewhere in it we're going to need a 3x squared. Let me just simplify it a little bit for a second. What if it was integrate just e to the t? So this one, the antiderivative is e to the t, and then evaluate that from 1 to x cubed. So we'd have e to the x cubed minus e to the 1. Okay, now this says, now take the derivative. So the derivative with respect to x of e to the x cubed minus e to the 1. So the derivative of the e function is the e function. And here's the part that I was talking about. Then the chain rule says you've got this x cubed function substituted into the e function. You've got to take the derivative of that. And then the derivative of a constant is 0. So we would get, well, it's essentially that function, the e function, but that thing is substituted in, and then the derivative of it is right next to it. Okay, so that means we would get, so you should be able to go right to the final answer now that we've done that. It's going to basically be that function with x cubed substituted in. So it's e to the x cubed over an x cubed. And then this part is basically saying, and also take the derivative of it. Or this part, the chain rule is saying, is also take the derivative of that x cubed. And there we go. The derivative of a constant would be 0, so there's no need for anything over here.